The topic for today's lecture is use of nanoparticles for the development of fingerprints. So, as we have discussed about fingerprints and what are the different methods for the development of fingerprints, we have studied about chemical methods and powder method, but there were drawbacks about those methods, right? Like for the powder method, sometimes you just use it in a more than enough quantity. Like if we need it in a minute quantity and you are taking it too much, that won't be needed. It's like a waste of powder over there. And sometimes we do use chemical methods that is not feasible to use it on the crime scene. Like we do need to develop fingerprints at the crime scene, but traveling with those equipments and chemicals at the crime scenes, it's crucial and it's not needed all the time. Yes, you cannot develop the fingerprints at all the surfaces using those chemical methods. So yes, because so like we do need a method that helps in developing the fingerprints of any surfaces, like it's on the polar surface, whether it's on the non-polar surfaces. So we do use powder method when we travel at the crime scene. But yes, as you have seen, they do develop the fingerprint. But what about the details? If it is a partial print, or if it is not that visible, it's blur, or some of the other reason it is not completely present at the surface, and you are using the powder method. So as we have discussed about the different levels of the uh, fingerprint pattern, like at the level 1 you can see the classification of pattern, that are the different pattern. Then level 2, the minutiae and the ridges that can be seen, and the level 3 is the pores that is present on the fingerprints. So, is it possible to develop all those prints using the powder? So that is what we are going to study today. Recent advancement in fingerprints, what are the recent techniques, what are the recent developments that have been done in fingerprints which are helping in developing the fingerprints at a better level, at enhanced level. So, today's learning objective of this lecture is Introduction to Nanoparticles, Significance of Nanoparticles, Application of Nanoparticles, and the role of nanoparticles for the development of fingerprints. So, if we talk about the introduction to nanoparticles, everyone is aware about the nanotechnology, like what is nanotechnology, and right now everyone is talking about it. So, what is so good about it? So, nanotechnology is one of the advanced branches of science that is focused on nuclear, subatomic, and supramolecular particles, planning to make nanostructure with improved functionality. So, if we talk about the size of the nanoparticles, it is ultra fine and small particles which ranges from 1 to 100 nanometer. Like even human hair is wider, like the width of the human hair is 10 to 550 micrometer, but nanoparticles, as the name suggesting, nano, so the unit is nanometer, so the size range varies from 1 to 100 nanometer. So nanoparticles can be classified on the basis of their size, shape, and material properties. So if we focus on the size, this size is uh, is helping, or you can say made them unique and have adjustable mechanical, electrical, and optical properties. So their size correspondingly permits them to have a brilliant and large reactivity and offers the capability to be modified by an innumerable of functional agents. Like you can add any other chemical or any other compound with it, and it will gives you a better result because of its unique adjustability property. It has a different mechanical, electrical, and optical property which can be adjusted due to the size variation. So yes, it is a brilliant idea to use the nanoparticles because it is adjustable. You can adjust it with any compound and it will give you a different kind of nanoparticle, and you never know what kind of application could be used for. Like for example, Nanoparticles can be used in the drug delivery, it can be used for the development of fingerprint, it can be used in question document examination. They are using the nanoparticles or nanopowder in sunscreen also. So there are n number of applications of nanoparticles. So it depends on what type of or in which form you are using them. Like for the development of fingerprint, we are using it in the powder form. So it can be made of nanorod, nano capsules. So it totally depends what is the use, what is the purpose. So yes, so nanoparticles have its own different unique properties. So if you see there are nanoparticle based technologies, we do use it for different purposes. There are n number of applications of nanotechnology. Like we have nanoparticles, we have nanorods. There are different possibilities of nanoparticles. So in general, if we talk about nanoparticles based technology, it has a center of opportunities for improving the efficiency, sustainability, and speed of already existing processes. So, all this is possible because we do have relative materials that can be used traditionally for industrial processes. Nanoparticle based technology use less material or large proportion of which is already in a more reactive state. So like we do need different catalytic processes, or to increase the speed or the reaction processes we use different catalysts. So but when you are using these nanoparticles, like you're developing the nanoparticles, it has some already reactive state properties which just helps in better development. So other opportunities for nanoparticle based technology includes the use of nanoscale zero valent ion particles as a field deployable. That means we are using it for the remediation of organochlorine compound. So yes, so these particles are able to permeate into rock layers in the environment or in the ground, and thus can neutralize the reactivity of organochlorine. So this is just one of the nano-based technologies we are talking right now. The properties of nanoparticles: they are highly mobile in the free state, they have enormous specific surface areas, they may exhibit what are known as quantum effects. Thus, nanoparticles have a vast range of composition depending on the use for the product. So, they have larger surface to volume ratio. They have this high percentage of atoms molecules on the surfaces. Many nanoparticles have unique light scattering property and exhibit plasmon resonance. Right now I'm just saying that we do have different variety of nanoparticles. So metal nanoparticles have their own property like light scattering and exhibit plasmon reference. Now if we are making the nanoparticles using semiconductors, they may exhibit confined energy states in the electronic band structure, can have unique chemical and physical properties, same size scales, and might be biological. Physical properties, if you say, nanoparticles are dependent on the size, shape, composition, crystal structure, surface ligands or capping agents, or the medium in which they are dispersed. So the physical properties are depending on these n number of. It also enhances electrical and heat conductivity, increased strength, tensile properties, magnetic properties, optical properties. They also helps in color change with the size, like the variation in the size also helps in changing the color. So yes, we can get a variety of color in the nanoparticle, like we do use different kinds of powder for different colors. So nanoparticle use different kinds of material for the preparation or synthesis of nanoparticles. You will be getting a variety of color at the same type of chemical or metal, or you can use semiconductor. So it has a variation in the size and shape. The nanoparticle affects many properties like the boiling point, the melting point, the band gap, the optical properties, electrical properties, magnetic properties. Even the structure of material changes with respect to the size of the nanoparticle. So yes, nanoparticles can be encountered as aerosols like solid or liquid in air, or suspensions solid in liquids, or as emulsions liquid in liquids. So it has a variety, it has a physical property, it has a number of chemical and physical properties depending on their size, shape, surface characteristics and inner structure. So there are n number of methods for the synthesis of nanoparticles. So depending upon the approach you want to proceed for the synthesis of it. So we have top-down approach, we have bottom-down approach, like what type of nanoparticle you want to make, like you want a powder one, you want the capsule, you want the nanosphere or the cluster. So depending upon that you can choose the method, like we have physical methods, chemical methods and biological methods, or you can say physical approach, chemical approach and biological approach. So if we say the physical methods, we have arc discharge method, electrical electron beam lithography, ion implantation, spray pyrolysis, vacuum sputtering, inert gas condensation. Then if we talk about the chemical approach, we have sol gel process, that is the most common one. Then phytochemical method, pyrolysis, microemulsion method, irradiation method, chemical reduction of metal salts. Then biological approaches, basically we are using plant and their extracts for the synthesis of nanoparticles. So this particular approach is green synthesis, or the green pathway for the formation of synthesis. Like in the chemical one or physical one, you are using the chemicals like separately, but when you are using the plant material or the extract, the plant has its own chemicals which are helping in the reduction or catalysis or whatever the process is needing over there for the formation or synthesis of nanoparticles. Automatically it's like it's the biological approach. So we can use the enzymes, we can use the biomolecules, we can use the bacteria, fungi, algae, microorganism, biological approach, that is. So this is one of the chemical method. So yes, we are mixing the alcohol and the titanium dioxide. So we basically or majorly use the metal for the nanoparticle formation. So it's mixing together. Then after that we are adding solution of nitric acid, and we are adding water into it dropwise for almost about 4 hours. So it's a long process, it takes time for the development or synthesis of nanoparticles. It's not like you're just adding it in full form. So yes, the method that we are using is sol gel formation. So drying in oven to vaporize the solvents. So it's like a wet gel plate on which we have poured that solution that we have mixed for 4 hours. Then calcination by furnace at 400 to 700 centigrade degrees. So using this sol gel method, we have synthesized the nanoparticles over here. Also used in the medicine, drug delivery, skin products. So in skin care products, mostly it is used in sunscreen. So in the diagram there you can see the formation of nanoparticle in agriculture, in the food processing, food safety, nutrition, adding to the nutritionals. We have different metals, calcium, titanium. So nanoparticle in petroleum engineering for the chemical enhanced oil recovery, for a better thermal enhanced oil recovery, for drilling simulation. So there are n number of uses or application of nanoparticles. So as I was saying about the sunscreen, so nanoparticles, the ingredient that is needed for the synthesis of sunscreen is majorly zinc oxide and titanium dioxide, or it contains a organic sunlight absorbing compound. So those materials are not satisfactory, or we can say zinc oxide and titanium dioxide are very potent photocatalysts. So in the presence of water and sunlight, they generate free radicals, which have the potential to damage skin cells and DNA also. So for like, if we do know that there's some harm, not in that quantity, like you do use it in the less quantity, whatever chemical we are using in these kind of creams, it should be in that dose which won't harm the skin. But like continuation use or some other factor, it might affect. So yes, scientists do try to find a better way or better product or chemical which won't harm us that much. So they try to develop nanoparticle form of titanium dioxide, like they use a titanium oxide for the formation of the nanoparticles and contain a small amount of manganese. So they added the manganese in those titanium oxide for the formation of nanoparticles. So that formation, that chemical, uh, nano-based sunscreen was safer than the sunscreen products we normally use, or we can say the conventional traditional cream that has been used is in over that the nanoparticle based sunscreen is better. So yes, so if we say about forensic nanotechnology, now if we talk about forensic, what are the application of these nanoparticles in forensic science? Like why are we studying nanotechnology? Like now there is a different branch, like there is a specific course for forensic nanotechnology, like MSc in forensic technology. It is a specialization now. So what is the purpose? Like how it is helping in forensic sciences? Like we can use the nanoparticles, we can use the nanosensors. It is also helping in DNA technology, then fingerprint development, then DNA sequencing, drug identification. Of course, toxicology, we do have toxicology, forensic toxicology. In that we can use the nanoparticles. Then in the document examination also, nanoparticles are playing their own role. Then trace evidence analysis. So there are so many applications of nanotechnology in forensic science. So if we just focus on the fingerprint, that is what we are studying. We do use different nanopowders, like which is made up of metal oxides, mostly silver nanoparticles, gold nanoparticles. Then we do have coated nanoparticles like carbon coated nanoparticles or polymer based nanoparticles. So yes, so traditional powder method that we normally use, and we are still in continuation of using those traditional powder that we use, that is black powder or white powder or grey powder, or we can say the silver powder and the fluorescent powder, then the magnetic powder. So these traditional powder dusting method has some disadvantage in terms of low sensitivity, less contrast, it is toxic in nature, and high autofluorescence intrusion. So therefore, to overcome these disadvantages and to get more accurate and precise result, use of nanoparticles has come into practice as a better choice. In the same direction, various researchers or scientists has tried to contribute it in developing those nanoparticles. Like there are n number of scientists who have till now have been trying to develop different kinds of different varieties of nanoparticles. Like if we are just talking about the silver nanoparticle right now, so size variation, like I have told, it is between 1 to 100 nano. So it can be of 10 nanometer, it can be of 12 nanometer. So as small as the nanoparticle, it would have been the larger surface area, and we do not need to use it in the larger quantity. So many scientists, researchers has been contributed by developing nanoparticles, studying their exploitation in the enhancement of invisible finger marks with better character development. So, the use of nanoparticle has recently shown a great potential in producing the next generation of fingerprints development technique known as nano fingerprint. So, one of the most important evidence found at the crime scene is fingerprints, since they are recognized as general proofs of human identity, as fingerprint is unique in nature. No two individuals has similar fingerprint, whether it is monozygotic twin. So that is the benefit of finding the fingerprints at the crime scene. It will be unique. So the nanostructure aids in the detection and expansion of later fingerprints. So we do have different nanoparticles, as I was telling earlier, like silica based, carbon, aluminium, copper, barium, iron, gold, silver has been industrialized to obtain latent fingerprints. So the general and individual characteristics of fingerprints and other minute details like the position of the pores can be and are enhanced by nanoparticles. This example, like we have the nanoparticles and we added the ligand molecule or the function molecule. So it just functionalized nanoparticles that we are using on the latent fingerprint for the development of print. So as you can see over there, developed like colorimetric fluorescence based detection of latent fingerprint. So it developed like this when we are observing it under the microscope or even the UV. See, it has clear details which you might won't get using the powder, the normal one. So yes, it gives an enhanced fingerprint. So if we say the significance, like we are getting the results from the normal powder, what is the purpose of using these nanoparticles? Why to waste time in developing or synthesizing these nanoparticles? No, we are not wasting our time. It is helping. So nanoparticles have been used to develop latent fingerprints, as it shows better enhancement of latent prints. It increases the superficial interface with the endogenic material present on the elevations, and it also enhancing the disparity and finger impressions, as most of the scientists focused on visualize the fingerprint at a physical level. So this helps in exploration of molecular level information embedded in the latent fingerprints. Like when you are using the powder, you are just developing it on the physical level, like surface where you have developed it, but what if you want to study it at the molecular level? So these nanomaterial based powders are helping us to develop it, and we can focus or we can explore the molecular level information also that is embedded in the latent fingerprints. So the stability of the nanoparticles with better sensitivity, or you can say the sensitiveness, showed a great visualization of the latent fingerprints, and you can see a better enhanced version of latent fingerprints using the nanoparticles. So that was the brief introduction of the nanoparticles. So yeah, nanoparticle development methods enhances the latent fingerprints in a better way. We can dope the nanoparticles, like you can combine the nanoparticles using other compounds like carbon dot space, silica oxide, core shell functional nanoparticles, which leads to enhancement of finger impression with all the details in it, like the individual and class characteristics of course, and the location of course can be seen using the single nanoparticles, which is sometimes quite difficult to see it in the normal powders or even the chemical methods. So the use of nanoparticles in latent fingerprints provide a different direction for forensic investigators. These nano-sized particles, when used as a development method in the latent fingerprinting, reflects numerous advantages over conventional method. These particles can easily be employed in a more precise way, and this reflects the better discriminity of nanoparticles over commercially available conventional materials that are used for the fingerprinting. So in short, they have the better quality. Less powder can be used for the enhancement of latent fingerprint. Gives more details, the level 1, level 2, level 3, all the details can be seen using these nanoparticles.